that small particles we have seen that the two types of nature is there. One is the wave nature and second is the particle nature. With the wave nature of the electromagnetic radiation, we could justify reflections, refractions, diffractions, all these things. But some of the phenomena could not be explained by the wave nature. These are the black body radiation we have already discussed. Photoelectric effect also we have discussed, and we have discussed the hydrogen spectrum. In hydrogen spectrum, we have found the lines are totally different. Okay, we are not getting a continuous spectra, but we are getting discontinuous spectra. So this discontinuous spectra gives us an information. Here the energy is not coming in a continuous way, but energy is being released. Once you excite the hydrogen atom, whatever the energy it gathers, and after that it starts radiating, and this energy is being released in a certain fixed amount of energy. So between them a gap is there. So when the energy is released in bundles, so this is known as quantum. So now this the knowledge of quantum is being incorporated to explain the atomic structure of an atom, model of atom. Bohr means it is a senior Bohr, Neil Bohr. Both father and son got Nobel Prize separately. So we'll now write Bohr's model of atom. So what the Bohr has done, he has modified the Rutherford model. Okay, I'm only writing this salient point because you can read from my note. So with the incorporation of the quantum theory, the Bohr could establish the stability of the atom. Electron is continuously revolving around the nucleus, but he could not explain where from the electrons are getting energy. Because if you take into consideration Rutherford model, by continuous loss of energy, the electron is going to come nearer to the nucleus, and ultimately it will fall inside the nucleus. Bohr has mentioned no. Electrons will remain in their own path. And as long as they remain in their own path, they don't have to spend energy, because it is the orbital or the path will supply energy. Just like that, if you walk on the road supports us. We do not go down the earth. We remain there. Road supports us. All right. So in that case, electron also will be supported by this. Okay. So this postulates one, the atom has a nucleus which contain, I'm writing in short form, which contains protons and neutron, because by this time neutron was already discovered. All right. Second, right here, the side of the nucleus is very small. I told you that it is 10 to the power 5 times smaller than the size of the atom. The negatively charged electrons revolved around the nucleus in a circular orbit. The force of attraction between the nucleus and the electron is equal to the centrifugal force of the moving electron. Third, out of the infinite number of circular orbits, around the nucleus, the electron can revolve only on those orbits, only on those orbits
So what's after centrifugal force of the
moving electron.
Thank you.
The electron can revolve only on those orbits whose angular momentum is an integral multiple of h by 2 pi. That is m d r to n h by 2 pi, where m is equal to mass of electron, v velocity of electron, r radius of the orbit, H is equal to Planck's constant 6.626 into 10 to the power minus 34 joules second, and n can be equal to 1, 2, 3, 4.
Sir, H is which constant, sir?
Yes, H is the Planck's constant. Planck's constant.
Thank you, sir.
Okay. Then 4. As long as the electron remains in any one of the orbitals, it does not lose energy. Such a orbital is called stationary state. That is, it does not move from there. Stationary state or ground state. Each stationary state is associated with with a definite amount of energy. The greater the distance from the nucleus, more shall be energy associated with these orbitals are numbered as K, L, M, or 1, 2, 3. These days we do not write KLM. The emission or absorption of energy in the form of radiation can only occur when an electron jumps from one stationary state orbit to another. So what we can write now here, delta E is equal to E2 minus E1. These are the energy associated with the orbits. And when it happens, it gives you the radiation H. So this is the Bohr's model of atom.
So can you please repeat the sixth point?
The emission or of absorption of energy in the form of radiation can only occur when an electron jumps from one stationary orbit to another. So this is the energy of one orbit, this is the energy of another orbit. When they move from one to another, they give either they absorb energy or they give energy, and that is equal to h nu.
Sir, that is H what, sir?
H nu.
Thank you, sir.
Okay. Now I'm going to write some equation from here. You can find out the energy. Just excuse me. So these equations are required for your numerical. Okay. See, how to calculate the radius of an orbit? Radius of an orbit. So the result right now here Rn. Okay, orbit of hydrogen. Is Rn equal to R1 n square. R1 is the first orbit. Huh? So R1 radius of the first orbit. Please remember. Radius of the first orbit is named after Bohr. This is known as, I'll write down the value. So it is 0.529 into 10 to the power minus 10 meter. This is called Bohr's radius. So first orbit is named after Bohr. So now, if you want to find out the radius of second orbit, so here I will write n is equal to number of orbit. So if you want to go for R2, R2 is nothing but 0.529 10 to the power 10 into 2 square. Okay, so it comes to 2.11 into 10 to the power minus 10 meter. Okay, now we'll write here now hydrogen like species. Okay, you write. Then I'll tell you what first. I'll tell you what is hydrogen-like species. So what is hydrogen? See, hydrogen has one proton and one electron. What is hydrogen-like species? Those species which has only one electron. See here. I'll take now here helium. Helium has two protons and two electrons. So if I have to make it hydrogen, if it has to be hydrogen-like, then it should contain only one electron. That is, if I subtract from helium one electron, then it will be He plus. So this is hydrogen-like species. Why? Because helium has two protons and two electrons. Hydrogen-like species must have only one electron because hydrogen, we have studied hydrogen with one electron. We are talking about the electron. Okay. So He plus is the hydrogen-like species. See here now. Now let us go for lithium. Has three protons and three electrons. So from lithium, because I have to keep only one, if I subtract two electron, what do I get? Lithium 2 plus. So lithium 2 plus is hydrogen-like species. So we'll write now here hydrogen-like species. Try to understand. This is called hydrogen-like species, means it should all the species which contains one electron, like hydrogen, we call them hydrogen-like species. So helium can never behave like a hydrogen atom, but if you can remove one electron, now it's going to behave hydrogen-like species. From lithium has three electrons, if I remove two, then it has only one, so it is going to behave like a hydrogen-like species. So remember this.
Excuse me, sir.
Yes.
Then the properties of lithium will change.
Yeah, no, we are talking about spectrum, dear. We are not going for its chemical properties.
Okay, sir.
Okay. So if you remove one electron from helium, then this spectra will be almost similar to hydrogen. Because the hydrogen spectrum is being taken for what? For the excitement of electron. We are not going for its chemical studies. Clear? So,
Yes, sir.
so these will be hydrogen-like species. Beryllium has 4 electrons. If I remove 3, then Be3 plus will be hydrogen-like species. So now I can extend this one into 4. So what we can write now here? Radius of orbit for hydrogen like species. Okay, so here the formula will be Rn equal to 0.529 into 10 to the power minus 10 into n square z. Okay, what is n? Number of orbit. What is z? Is the atomic number. For helium it is 2. For lithium it is 3. So n is equal to orbit number and z is equal to atomic number. See, you with this you can calculate for hydrogen also. Why? Because this is a general formula. What is the atomic number of hydrogen? 1. See, same thing you have written here. See, same thing. All right. Now we are going to calculate the energy, orbit wise. In which orbit electron will have what energy? Because every orbit will have different energy of orbit.
Excuse me, sir.
Yes.
So can you just tell me what was Z, because I was facing some network issue.
Z is the atomic number.
Oh, okay, sir. Thank you, sir.
Energy of orbit of hydrogen. So the general formula is En. N can be 1, 2, 3. Minus 21.79 into 10 to the power minus 19 divided by n square. N is the number of orbit. This is joule per atom. Okay. So that is equal to how much? 2.18. We have just made it this thing. 10 to the power minus 18 by n square joule per atom. Nothing here. From here we shifted one. Okay. Now, this is different unitary using. Into minus 13.6 n square electron volt per atom. Why? Because 1 electron, 1 joule is equal to 6.24 19 into 10 to the power 18 electron volt. Okay. En minus 31.36 by n square kilocalorie mole inverse, or depending on what type of numeric is given. I don't know that you will be able to remember dot dot. The last one you try to remember is 1312. This is easy for you to remember. 1312 n square kilojoule mole inverse. This is for hydrogen.
Excuse me, sir.
Yes.
Can you please tell how did you get the values?
Oh, these are these different conversions done. From the conversions that are 1 joule is to how many kilo. So they have kilocalorie by this one.
Okay, sir.
This value of the joule and calorie, you can get it from the physics book. Okay.
Okay, sir. Thank you, sir.
Now for hydrogen, like energy of orbits of hydrogen like species. So En is equal to E1. E1 is to get it from this. It's for hydrogen. Into Z square by N square. So now you know number of orbit and Z is the atomic number. So E1 energy of first orbit of hydrogen. So what will be the first orbit of energy? See here, N is equal to what? 1 or not? So do 1312. Understood now? Huh? So is equal to what? 1312 kilojoule mole inverse. And Z is equal to what? Atomic number. For helium it is 2 and for lithium it is 3. Note down this one.
So what you write E1 energy of
Okay. Wait, let me see now. What should I teach? Now let us see what is the weakness of Bohr's model. This may come in the exam. Weakness of Bohr's model of atom. One. It does not explain the spectra of multi-electron atoms. See, it's the greatest disadvantage. See, if I have to know the spectrum of helium, I cannot take helium atom. I have to remove one electron from it. It is very difficult to remove one electron from helium. If I have to go for lithium, then I have to remove 2 electrons of lithium. So it is very, very difficult. So this is major fault with the Bohr's model atom, that we cannot accept hydrogen. We cannot study the spectrum of the other atoms because they have more than one electron. Second, he does not explain the splitting of spectral line of hydrogen spectrum which splits into finer lines under the influence of electrical field electric field. Stark effect and magnetic field. Zeeman effect. You write it, I'll explain. These were the spectrum which you got. I'm not playing the line. Okay, so these are this. But suppose you have kept the hydrogen in an electrical field. You'll find this you think is one line, two line, third line, fourth line, fifth line. It is found the first splits into several fine lines. Similarly, you'll find the second line also splits into several fine lines. Then this also splits. Okay, these are called fine splitting. If you observe under microscope, you'll find, or magnifying glass, you'll find these are like this when you put it in electrical field. When it happens in electrical field, we call it Stark effect. And if you place in magnetic field, we call it Zeeman effect. But this atomic Bohr's model of atom cannot explain. Right. Bohr's model of atom cannot explain de Broglie's concept and Heisenberg uncertainty principle. This we are going to explain now. Anyway, both these things happen after Bohr's model of atom, but the atomic model should have the capacity to explain. It does not explain three-dimensional structure of both Rutherford and Bohr, and the Bohr has considered that atom is two-dimensional. It's just like a circle, but actually atom is three-dimensional. It is spherical. It does not explain the shapes of molecules. This is important for your exam. Both Bohr's model of atom and its weakness.
Sir, sir, can you read? Can you dictate again? Number 2.
Number 2.
Yes, sir.
It does not explain the splitting. It does not explain the splitting of correct. Explain the spectral line of hydrogen spectrum. It does not explain the splitting of spectral line of hydrogen spectrum, which splits into finer lines. under the influence of electric field. Under the influence of electric field, within bracket you like Stark effect, STARK, Stark effect. And magnetic field, within bracket Zeeman effect, ZWMAN.
Thank you, sir.
Okay, now we'll go for the Booglish equation. Okay, so now we'll go for dual nature of matter. Dual nature of matter. What is the meaning of this? Dual means there are two types. What is the dual nature of matter? That is, we find matter has both particle behavior and wave behavior. They exhibit the properties of wave as well as they exhibit the properties of particle. Okay. So we call it wave nature of material part. See here. Let me draw this wave. Okay. So can I not write it like this? If I put several points and if I bring them very close to each other, will it not look like this? Okay. Many a time when you draw something and if you feel that your hand is not free, we try to initially draw an outline with dots. And we put the dots very close to each other, almost connecting each other. So if you connect it, it becomes a wave. Okay. So because of that, we call it wave nature of material particles. These are the particles. When they have come very close to each other, it behaves like a wave. Okay. So we'll write here who has proposed this theory? Einstein initially. Einstein has suggested that light can behave as a wave as well as light a particle. See why Einstein used to say like that because we have found light shows some property like reflection, refraction, diffraction. These are the property of waves. But the same light when falls on potassium, rubidium, cesium, they can eject one electron after another. That is, in that case, light behaves as a particle. So these are not imagination, these are reality. And it is being proved. Okay? So all material such as electron, proton, neutron, atom, molecule, etc. in motion have dual nature. That is, both as wave exhibit both wave character as well as particle character. Now, Jyoti has sent me a message that it is difficult for her to attend the class before 4 o'clock. See, Diproglis, the name, first alphabet is not capital because though it is a name, it is small. This is a Spanish way of writing the name. D. The second word, it starts with A. Diproglis concept. You will find the similar equations are there with the case of van der Waals. So van der Waals name is van der Waals. It starts with van, but V is not capital, small. De Broglie suggested that all material particles in motion possess wave characteristics. It is given by the equation lambda is equal to h by p, or lambda is equal to h m. Okay, I'll write down here. What is it? Okay. This equation is known as de Broglie's equation, where lambda is equal to de Broglie's wavelength. Then h is equal to Planck's constant. That value I need not write, you know it. P is equal to linear momentum. Okay. You know momentum, linear momentum is equal to what? Mass into velocity. What is m? Mass of the particle. What is v? Velocity of the particle. After finishing, you tell me.
Done, sir.
Okay. Now we'll go for the derivation. How to derive this formula. This is important for your exam. Derivation of de Broglie's equation. Right now, yeah. According to Max Planck, E is equal to H mu. That we know it. We have done it. We discussed also. Okay. Okay. Then what should I write? And according to Einstein, E is equal to mc square. Okay. What is m? M is the mass of the particle and c is the velocity. Is mass of the mass of photon and is equal to velocity of light. See, this is particle. Okay. So now let us combine both the equation. Combining these equations what? See here. So I can write here now H nu is equal to mc square, like equation 3. We know what you know, dear. Nu is equal to what? Remember? Nu is equal to c by lambda. So I put this equation here. Therefore, H is equal to c by lambda is equal to mc square. So c and c will get cancelled. What we can write? So you can write here equation 4. So, or I can write H by lambda is equal to m into c. Okay. Now, specifically used for electromagnetic radiation, but we want to apply it for other particles. Other particles may not move at the speed of light, but they are very small as electron. So what we can write? Substituting velocity of light c by velocity of a particle v, we get
Sir, you have frozen. The screen is
because linear momentum is equal to what? Mass of the particle to this equal to what? mv. So this I'll put in the bracket. So this is my final equation 6 and this is 7. So ultimately we have proved. See, this is a very important milestone in physics and the structure of atom, that someone has find a scientific relation between wave and the mass. Huh? Wave and the particle nature. Because particle must have mass.
Sir, can you please repeat the line linear momentum again?
Linear momentum equal to P. This is the symbol P. Is equal to what? Mass of particle and velocity. So what is the mass of particle? M. And what is velocity? V. This is going to come in the exam. They will ask you 100% chance. First unit test that you are going to get. They will ask you derive de Broglie's equation.